One of the most important concepts in chemistry is dimensional analysis. If you learn this in math, it is called factor label. It is a method to convert from one unit to another by using conversion factors. Conversion factors are anything that are equal to each other or equivalent. So you know that 1 yard is equal to 3 feet. This is a conversion factor. These are equal to each other. Whether I say 1 yard or 3 feet, you know they mean the same thing. Whenever I use dimensional analysis, the first thing I want to do is start with what's given. So if there's one number, then you start with that one given number. If you are converting a numerator and denominator to a different numerator and denominator, that is the value that you start with. Number 2, you need to figure out what your conversion factors are. These conversion factors allow you to convert from one unit to another. If you are stuck, the next step you want to do is make sure your diagonal units are the same, because diagonal units are the only way you could cancel out units. Number 4, calculate using correct significant digits and units, always. So let's look at our first problem, in which we have 530 seconds that needs to be converted to days. We know that we could do this in the calculator, but we must show work. In order to show work in dimensional analysis format, you need to find conversion factors. We don't know how many seconds are in a day, but we know that there are 60 seconds in 1 minute. We also know there is 60 minutes in 1 hour, and we know there are 24 hours in 1 day. These are, again, conversion factors, and they're equivalent to each other, meaning that if I say there's 60 seconds or 1 minute, it means the same thing. First thing you always want to do after you find your conversion factor is start with what's given. What's given is 530 seconds. Next, diagonal units must be the same to cancel out. So in math, to cancel out a unit in the numerator, there must be a same unit on the denominator. So if the unit is seconds, the bottom unit has to be seconds. Now we go back to the conversion factor. The only conversion factor with seconds in it is the top one. The number in front of seconds is 60, so we put 60. This is equal to 1 minute, so that goes on top. The seconds cancel out. If I stop here, my answer is in minutes, and we do not want minutes, we want days. So we need to continue on. Again, we start with diagonals. Since the numerator is minutes, denominator has to be minutes. The conversion factor states there's 60 minutes in 1 hour. The diagonal units cancel out, and we are left with hour. If we end here, our final unit is hours, but we want it in days, so we need to continue on. So if this is hours, my diagonal has to be hours. There are 24 hours in 1 day. 24 hours in 1 day. All my units cancel out. My final unit is day, which is correct. Now I'm going to multiply all the numerator. So that is 530 times 1 times 1 times 1. I'm going to multiply all the denominator, which is 60 times 60 times 60. And then we're going to divide numerator divided by denominator. This equals 0.00613425993. Since we are doing math, we must do significant digit each time. When I do dimensional analysis, we never use conversion factors as part of significant digit because in general, most conversion factors will always have one sig figs. So we ignore the conversion factors. That means we are left with only the initial number, which is 530. So the number of sig figs in 530 is 2 because that 0 is trailing. So I need 2 in my answer. So I start at the left. I go to the first non-zero digit, which is 6. I count 2, 1, 2. I look 1 to the right. Since it's below 5, the 1 remains. Remember, we must put the zeros as placeholders here. Days is my answer, 0.0061. Pause the video, try this one on your own, and then check your answer. Here we need to convert 7.580 micrograms to megagrams. In general, most of us cannot go from microgram to megagram, so we are going to go to the base unit. The base unit is gram. There are 2 ways you could set this up. If you make the bigger prefix 1, the micrograms becomes a positive exponent, 10 to the 6. So 1 gram has 1,000,000 micrograms. If you decide to make the smaller prefix 1, so that means 1 microgram, the bigger prefix is a negative exponent, which is 0.5 zeros and a 1. Either method is correct, just set it up correctly. So we need to go from grams to megagrams. The bigger prefix is mega, so that gets the 1, and this is 10 to the 6 grams. If you choose the other method, smaller prefix is 1, so megagrams gets a negative prefix. So one more time, if you make the bigger prefix 1, all the exponents for the prefixes will be a positive exponent. If you make the smaller exponent 1, then the exponent for the bigger prefix will always be negative. So we're going to start with what's given, which is 7.580 micrograms. I do my diagonals, micrograms, micrograms, to cancel out units. The number in front of micrograms is 10 to the 6. What's left over? 1 gram. That goes on top because they're equal to each other. I need to go again because if I end here, I end up with grams as unit. Diagonals, grams, grams. The number in front of grams is 10 to the 6th. What's left over is 1 megagram. I could also use the pink conversion factor, which are the same. If I set that one up, it's pretty much the same method. Micrograms. What is the number in front of micrograms? 1. Diagonal units are still the same. On top, 10 to the negative 6 grams. I need to go again. Grams, grams. If this is 1, this is 10 to the negative 6 megagrams. So you're going to multiply 7.580 times 1 divided by the denominator, which is 10 to the 6 times 10 to the 6. Divide both, and you should get 7.58 times 10 to the negative 12th megagrams. Now I need to go back and do sig figs. Conversion factors do not count. Conversion factors do not count. There are 4 sig figs, decimal, significant digits, so the 0 is significant. I have 3, so I need to add a 0 at the end. If I multiply the bottom one, 7.580 times 10 to the negative 6 times 10 to the negative 6 divided by 1 times 1, you will still get the same answer. And with correct sig figs, the answer should be exactly the same. Pause the video, try this problem on your own, and check your answer. So we need to convert from micrometers to centimeters. If you do not know how to convert from micrometers to centimeters directly, you must go to base. We know that meters is the bigger prefix, which will get 1. This is 10 to the 6. Meters to centimeters. We know the meters is the bigger prefix, so that gets 1. And centi is 10 to the 2nd, or 100. So I'm going to start with what's given, which is 4.08 micrometers. Diagonal units need to be the same to cancel out. So if the top is micrometers, the diagonal has to be micrometers. The number in front is 10 to the 6th. What's left over is 1 meter. The micrometers cancel out. This is meters. This is meters. The number in front is 1. What's left over, the equivalence, is 100 centimeters. So now you're going to multiply 4.08 times 1 times 10 to the 2nd divided by 10 to the 6th times 1. If you do your math correctly, you should get 4.08 times 10 to the negative 4th centimeters. Now we need to go back and do sig figs. Conversion factors do not count. Conversion factors do not count because in general they will have 1 sig fig. I look at the initial. There are 3 sig figs. That 0 is significant because it's surrounded by a significant digit, or there's a decimal and a significant digit in front. And my final answer also has 3. You could also set this up making the smaller prefix equal to 1. If I use the smaller prefix equals to 1, then the bigger prefix will have a negative exponent. 10 to the negative 2 meters is equal to 1 centimeter. And if you set it up, it will still get the same answer. So micrometer, diagonal is micrometer. Number in front is 1. On top is 10 to the negative 6 meters. Micrometers cancel out. Meters, this is meters. Centimeters. There's 10 to the negative 2. And this is 1. And if I do my math, I will still get the same answer with correct sig figs. In general, I will use the bigger prefix as 1. So the prefixes will have positive exponent. You could use either method, just do it correctly. Pause the video, try this problem on your own, and check your answer. We know that a kiloliter and centimeter cubes are volume units. We cannot go from kiloliters to centimeters cubed directly, but we know that 1 milliliter is equal to 1 cubic centimeter, and you need to memorize this conversion. Since we know milliliter is equal to centimeter cube, I know I need to convert kiloliters to milliliters first. If I do not know how to go directly from kiloliters to milliliters, I need to go to base, which is liter. So kiloliters to the base, which is liter. Bigger prefix is kilo, so that gets to 1. There's 1,000 liters. Next, we're going to go from liters to milliliters. Bigger prefix is liters, so that's going to get to 1. And milliliter is 1,000. I'm going to start with what's given. What's given is 99.30 kiloliters. I start with the diagonal units. The diagonal units, kiloliters, has to be kiloliters. The number in front of kiloliters is 1, right here. This is equal to 1,000 liters. So I put that on top, just like that. The kiloliters cancel out. This is liters. This is liters. Diagonal units have to be the same. There's a 1. This is a 1. What's left over is 1,000 milliliters. Next, milliliters to milliliters. I could go to cubic centimeters because we know that 1 milliliter is equal to 1 cubic centimeters. So this is the setup. Now I'm going to do my math. So 99.30 times 1,000 times 1,000 times 1 divided by 1 times 1 times 1, which is equal to 1. This will give you 9.93 times 10 to the 7th. Now I need to go back and do sig figs. Conversion factor doesn't count. Conversion factor doesn't count. Conversion factor doesn't count. There are 4 sig figs. There's a decimal significant digit in front, so this 0 is significant, so all significant digit. My answer only has 3, so I need to put a 0. And then the last thing I need to do is make sure I have proper units. Pause the video, try this problem on your own, and check your answer. So kilometers cubed is a derived unit. It measures volume because it's a kilometer times a kilometer to a kilometer. We're converting kilometers cubed into centimeters cubed. Most people don't know how many kilometers cubed are in a centimeters cube or how many centimeter cube are in a kilometer cube. But we know how many kilometers can be in a centimeter. If you don't know, go to base. So if I go to base, kilometers to meters, bigger prefix is kilometers, so that will get 1. There's 1,000 meters in 1 kilometer. From the base, I could go to my centimeter. Bigger prefix is 1, which is the meter. There's 100 centimeters. I'm going to start with what's given, which is 1.00 kilometers cubed. I know my diagonal units have to be kilometers cubed. Right now, I'm going to leave it as kilometers because I know that I have 1 kilometer can equal to 1,000 meters. Why? We know this conversion factor. 1 kilometer is the same thing as 1,000 meters. Since the unit is cubed, I need to cube the number as well as the unit. If I do cubing on the bottom, in math, I need to do cubing on top. So now my kilometers cube cancels out. But if I leave it like this, I am left at meters cubed. I want my final answer centimeters cubed. So I'm going to continue on. My diagonal units again has to be meters cubed. I'm going to leave it as meters and I'm going to fill it in first. 1 meter is equal to 100 centimeters. 1 meter is equal to 100 centimeters. Afterwards, I need to cube. Why? My units are cubed. Cube the number as well as the unit. And if I do it on the bottom, I need to do it on top. If I cube on the top, I need to cube on the bottom. So I need to multiply this out. When I multiply this out, 1,000 cubed is 1,000 times 1,000 times 1,000. 100 cubed is 100 times 100 times 100. In the denominator, 1 kilometer cube is 1 times 1 times 1, and 1 meter cube is 1 times 1 times 1. If you do all the math, you get the following: 1 times 10 to the power of 15 units of centimeters cubed. Now we need to go back and do sig figs. Conversion factors do not count. Conversion factors do not count. There are 4 sig figs. There's a decimal significant digit in front. These zeros are significant. I have 1 in my answer, so I need to add 3 more zeros to make it 4, because in scientific notation, all the numbers in the front are significant. Pause the video, solve this problem, and check your answer. So we're going from hectosecond squared to megasecond square. Since we don't know hectosecond squares to megasecond square, we probably want to go to base. So instead of using the initial derived unit, we're going to use the fundamental units. We know the conversion of a hectosecond to a second. Hecto is the bigger prefix, so it gets 1. There are 100 seconds in a hectosecond. We need to go to seconds to megaseconds. Bigger prefix is mega, which is 1. There are 10 to the 6 or a million seconds in 1 millisecond. So I'm going to start with what's given. This is hectoseconds. So my diagonal unit has to be hectoseconds too, but it has to be square. So we're going to start with hectoseconds. The number in front is 1. This is equal to 100 seconds, so that goes on top. Now, since hectosecond squared is a derived unit, it's squared. I need to square the number and the unit on top and bottom. When I do that, the hectosecond squares cancel out. We're left at second square, but we don't want the answer in second square. We want it in megaseconds. So I continue on. We're going to write it as just seconds. We know there are 10 to the 6 seconds in 1 megaseconds. It has to be square. So I'm going to square the top and the bottom. So when I multiply this out, this is 100 seconds times 100 seconds. This is 1 megasecond times 1 megasecond. In the denominator, it's going to be 1 hectoseconds times 1 hectosecond, and 10 to the 6 seconds times 10 to the 6 seconds. So the answer is 3.4 times 10 to the negative 11th. With the units of megaseconds squared, now I need to go back and figure out the sig figs. Conversion factors don't count. Conversion factors don't count. So I look at my initial number. These zeros don't count. They're placeholders. There's a decimal, no significant digit. The last zero counts because there's a decimal present, significant digit in front. So there are 3 sig figs. Right now my answer has only 2 because in scientific notation we count everything in the front, so we need to add a 0. So my final answer is 3.40 times 10 to the negative 11 megaseconds squared. Set up this problem on your own and check your answer. In this example, 0.0100, we need to convert the kilometers to millimeters, and we need to convert hours to second. So my conversion factor, if you do not know from kilometers to millimeters, we're going to go to base. So kilometers to base, which is meter. Bigger prefix is kilometer, so that gets to 1. There's 1,000 meter. We also know that meters to millimeters. Bigger prefix is meters. That gets to 1. This is 1,000 meters. To go from hours to second, if you don't know, go to hours to minute. Bigger prefix is the hour, so that's 1, 60 minutes. And we also know 1 minute has 60 seconds. After you determine your conversion factors and what you need to convert, we need to start with what's given. What's given is 0.0100 kilometers per hour. The way you want to set up your units for dimensional analysis is you want to put the kilometers on top and you want to put the hour unit on the bottom with the horizontal line representing the division. So I'm going to convert the numerator. To get rid of the numerator, we know that kilometers and kilometers have to cancel out, so diagonal units have to be the same. 1 is the number in front of kilometers. Equivalent is 1,000 meters. The kilometers cancel out. I continue on. because if I end here, I'm going to end in with the units of meters, and we want them in millimeters. So diagonal units, this is meters, this is meters, units cancel out. Bigger prefix is 1, so that's the 1, and this is 1,000 millimeter. So I have the proper units for the numerator, which is millimeter. Now I'm going to convert the denominator. Since the unit is in the denominator, to cancel it out, this unit has to be in the numerator. Diagonal units cancel out. The number in front of ours is 1. It's equal to 60 minutes, so that's what I put on the bottom. If I leave my answer here or I stop, it's going to be in millimeters per minute. We want it in seconds, so I need to continue again. Minutes is in the denominator. To cancel it out, it has to be plates diagonally on top. There's 1, 60 seconds. So 1 minute is equal to 60 seconds. So now I need to multiply 0.0100 times 1,000 times 1,000 times 1 times 1 for the numerator. And the denominator is 1 times 1 times 60 times 60. And you should get the answer of 2.77777. Repeating. I need to go back and do sig fig. Conversion factor doesn't count. Conversion factor doesn't count. Conversion factor doesn't count. Conversion factor doesn't count. So it's the first set of numbers. These zeros are not significant. There's a decimal, no significant digit in front. These zeros are significant, but there's a decimal and a significant digit in front. So there's 3 in the answer. I start at the left. 1, 2, 3. I look 1 to the right. It is greater than 5, so I round up. And then proper units. Numerator is millimeters. Denominator is second. And that is the unit that you want from here.